Alright, so our strategy is pretty simple. We try to marry the information in our little descriptive paragraph to the diagram as far as is possible. Hence, we do all our solving off of this. Well, first off, we have x over there and 2x. These are line segments kf and mk, which are given over here. And then we also have ml being given y as a parameter over there. And we can see we have parallel lines over here. So let's have a look. Let's see if we can find something. Okay, so right off the bat we have corresponding angles over there that are going to be equal. On the other side, K1 as well as angle F. So no need to demarcate them right now. Well, with those parallel lines from those 2x and x is over there, sort of already see, don't worry about that, but the same ratio or proportion will have to hold over there, which means that's going to end up being 2y, which means that's going to be y and that's going to be y, because 2 divided by 2, these being equal line segments, so that's going to play a part as well. So yes, that sort of does the job of doing that, and now we can go and have a look at our questions. Okay, let's see. Radio. So as you can see, I've sort of prepared that over there. So first things over there. Well, we have that, and that as a question. So first things first. Give a reason why angle GFM. Well, GFM, let's have a look at where that is. Well, G, F, and M towards there is equal to L, KM. As we can see, they are the parallel lines. So for this, we are just going to have, well, happen to be corresponding angles. And then never forget, quote your parallel lines. So KL parallel to FG. And that's all that's being asked of us. Now they want us to prove that GH, this line segment, is equal to the Y that is spot over there. So what remains is to structure that properly. So let's start off with what we see. Well, the rule of thumb is to say it's what you want over what you have. However, it is GL that is part of the proportionality. So it's GL and LM. So if we use it, we have GL over LM. Like I said, the rule of thumb, what you want over what you have. So that's kind of what you want over there, or want to start doing. Well, how does that translate? Well, that will come from having KF or FK over MK. Now it's just a question of filling in what we need. So we have GL is equal to, well, HL, this line segment over there, plus GH. So let's just split that up. It's GH plus HL. Well, what is LM? Well, that's just Y, and that is equal to, what is FK? Well, 2x over MK, which is just x. Well, let's follow the math. That just cancels out. Well, now what do we have here? Well, GH and HL are equal to each other. That's just from the diagram. So we're going to say here that, okay, that's 2 times GH. And from cross multiplying, we have 2 times Y. Then we quote that reason there, because we were given that GH is equal to HL. As you can see, if we divide both sides by 2, what is required just falls out of the equation. GH being equal to Y. So that's good enough for that. Then next, well, they want us to prove that triangle MFH is similar to triangle MGF. So let's have a look at that. Bear with me over there. MFH. That's the one triangle. Let's mark the other triangle in a different color. Let's choose blue. MGF. that's just a big triangle MGF. As we can see over here, that part's going to be easy because that angle is common. Now we need another angle. Well, as we can see here, well, what I marked over there but forgot to discuss initially were these equalities over here. So we need to prove that F2 is equal to angle G. So let's have a look at how we do that. Well, first off, we're going to say that angle L1 is equal to angle G. Why is that? Well, they happen to be corresponding angles, and let's never forget, well, that's because LK happens to be parallel to FG. And then we can also say that angle L1 is equal to angle F2 right over here. Let's just re-emphasize that. Why? Because it's the external angle of a cyclic quadrilateral. Well, as we can see, the left hand sides are equal, therefore the right hand side needs to be equal, and that gives us that, well, angle F2 is equal to angle G, which is the conclusion we wanted to draw. Now we can start off with our similarity proof, because we have enough. Two angles are enough, and these being those two angles, we need those corresponding angles to equate to each other. So in triangle MFH and triangle MGF, what do we have? Well, angle M is common. Then we have, well, angle F2 being equal to angle G, and that is of course proven above. And then finally we have angle MHF being equal to, well, just angle F, the entire angle F, and that's MHF, and that's the entire angle F, and those are of course the third angle in a triangle. Just for this proof, lastly, triangle MFH is similar to triangle MGF, which is what we want, which means we now have MF over MG being equal to FH over GF being equal to MH over MF. Well, there we have our proportionality set up, and that's quite good. Right, on to the next question. So let's just see, let's get rid of the things we don't need, which would be those. Yeah, I can go to, let's just see if we can move this somewhere until we need it. There you go. Make it smaller. Well, that goes there. What's our next question? Well, we're required to prove that GF over FH, that bit over there, is equal to 3x over 2y. Well, I can say that well, now I'm required to prove that GF over FH is equal to 3x over 2y. So let's have a look. GF over FH. Let's have a look at that. Where can I go and collect that? Well, if you can see here, they have GF and they have FH. And now, if I look at my proportionality, I can see that MF is this part over here. That's composed of this x and that 2x. So there is my 3x. And then image, which is just from there to there. Now, given that I've proven that this part is y, that's also 2y. And that's exactly what I need. So there's my 2y, and there's my 3x. But as you can see, it is just flipped. But that's the beauty of proportionality, in that the reciprocal ratios also form a proportionality. What does that mean? Well, if I swap the numerator for the denominator here and I do it right through the proportionality, left to right, then it holds true. Hence, I can say GF over FH is equal to MF over MH. And what's my reason for this proportionality holding true? Well, it's quite simply that triangle MFH is similar to triangle MGF, as I just proved, and that turned out to be useful. So now it's just, well, substituting the parameters that I saw over there, and as you can see, MF is 3x and MH is 2y as required. Again, let's just move on. Well, for the next one, well, we're required to prove this. So let's see what we have over here. Let's just see if we can go get that proportionality back. There we go. Copy it and come back. Nicely done. Well, let's see over here. GF FH. There we go. Well, we now know what GF over FH is. Well, we know this is 2y. So that's there. And then we can see that MF and MG also can play a role over here. Why? Because MF is still going to be 3x. Look at it. There. And then MG, that entire length over there is 3y. So that might be useful, because 3y over 3y gives me a y over x, because the 3's will cancel out. So in this case, I'm going to use that proportionality. So I'll state it as, well, GF over FH being equal to MG over MF. Why is that? Well, again, it's because triangle MFH is similar to triangle MGF. And if we have a look at that, proper substitution will give us 3x over 2y being equal to, well, 3y over 3x. Well, 3's cancel out. Now I can just cross multiply. So we'll have 3x squared being equal to 2y squared. Divide both sides by x squared, and so we'll divide this side by x squared, but we have to do it this side as well, and then we'll divide both sides by 2 as well. So that happens on that side, and that happens on this side. Therefore, y squared over x squared, as we can see, is equal to 3 over 2. Take the square root on both sides, and that gives us y over x being equal to, well, we can do better than that, the square root of 3 over 2 as required, and it has to be positive because we're dealing with positive lengths, obviously. So with a bit of preparation and forethought, and especially making sure that we maintain and update our diagrams, we can make sure that we make make this as simple as possible. Also, practice does make perfect.